Dear all, my name is Елизавета Lavrova. Let me introduce you our work which is devoted to radiomics analysis of white matter on clinical and quantitative MRI. On this slide you can see conflict of interest disclosure. In clinically isolated syndrome, brain lesion load is a prognostic marker. The unmet clinical need is an aid for rapid automatic check for white matter abnormalities, including lesions. The common clinical tool in multiple sclerosis is MRI, as it has an appropriate contrast, but the images are expressed in arbitrary units, which makes it challenging to perform automated analysis. Within this study, we hypothesize that MRI-based white matter radiomics features are able to distinguish between multiple sclerosis and non-multiple sclerosis brain. While dealing with clinical MRI, we're dealing with a signal measured in some time point and producing just a visual contrast. But if we would measure a signal in multiple time points, we would be able to estimate physical properties of the tissues producing this signal. Therefore, we would be able to produce quantitative maps of these tissues. In the present study, we've been working with a dataset from Liège containing both MRI and quantitative MRI of multiple sclerosis and non-multiple sclerosis brain. For external validation of T1 weighted based models, two open source datasets were used. Caligari-Campinas 359 containing data of healthy controls and multiple sclerosis segmentation challenge dataset containing data of multiple sclerosis brain. Further, for classes balance during validation, data resampling is performed. Radiomics pipeline contained the following steps: image preprocessing and segmentation, radiomics features extraction from white matter region, selection of the best performing features, binary classification with logistic regression model. On the slide, you can see binary classification accuracy scores. Expectedly, the highest accuracy is achieved with combined quantitative MRI data. The outperforming quantitative MRI modalities are magnetization transfer, MT, and longitudinal inverse relaxation time, R1. The poorest quantitative MRI modality is proton density, PD. Clinical T1 weighted data performs with less accuracy than leading quantitative MRI modalities. Results obtained with external validation are in line with the results obtained on original dataset. The main limitations of this study are related to available data. First, as original dataset has a relatively small size, the results of this study are only indicative. To have a better interpretation, more data is needed. The second limitation is related to absence of quantitative MRI data publicly available, which makes it impossible to perform external validation for quantitative MRI-based models at the moment. To sum up, with this study, we've demonstrated utility of radiomics and quantitative MRI approaches in multiple sclerosis diagnosis. Future potential of white matter MRI-based features is shown. On this slide, you can see information about study ethics committee approval and funding. Thank you for your attention.